you guys learned about center of mass, correct? So where all the mass of the body is concentrated. Now we have one more important concept called center of gravity. Okay, now to figure out what is center of gravity, see, you have a single point, okay, the single point of the body on which the weight of the entire body is concentrated, that is center of gravity. Okay, let's say we have W1, W2, W3 till Wn. See, these are the weights of all n particles of the body. Okay, now all these things, they have to act at different positions, correct? So let's say they are acting at R1, R2, R3, Rn. Okay, then the position of the center of gravity, okay, center of gravity is where all the weight is concentrated. So that will be R is equal to W1 R1 plus W2 R2 dot 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 till Wn Rn divided by W1 plus W2 plus W3 till Wn. Okay, in other words, we can write this in sigma notation, which is sigma Wi Ri divided by sigma Wi. Okay, now see, this is the position, but remember we are talking about vectors here, right? What if I have the coordinates, like in terms of x, y and z? Then in terms of coordinates, we have xcg, center of gravity. Xcg is equal to W1x1 plus W2x2 till Wnxn by W1 plus W2 plus W3 till Wn, or sigma Wixi divided by sigma Wi. Okay, similar way we have for y also, ycg sigma Wiyi divided by sigma Wi, and zcg is equal to sigma Wizi divided by sigma Wi. Okay, so this gives us the position of the center of gravity, right? So if this is the center, the position of the center of gravity, now what is weight? See, weight is basically mass times the acceleration due to gravity, correct? Because W is equal to m into g. So wherever we have W, we can substitute as m into g, correct? Right? Each time the mass will vary, but the center of the acceleration due to gravity will be the same. Like if you have, let's say you have a basketball, each and every particle, it will have the same acceleration due to gravity, correct? Like if you take it, every particle on the ball, so mass can vary but g will be the same, correct? So using that concept here, we change W is equal to m into g. Alright, and then we'll try to figure out what the formula will change it to. So we'll get RCg is equal to sigma Mig Ri divided by sigma Mig. Understood? Mass will vary but g will be the same. G and g gets cancelled. So what did we end up with? We end up with sigma Mi Ri divided by sigma Mi. Don't you think this is the same formula for the center of mass also? Right? So for known bodies, okay, for known objects, the position of center of mass and the center of gravity coincides. Okay, and usually this is the scenario. Okay, usually this is the scenario for almost all of them. There are certain cases where these two will not coincide. Okay, there are certain cases. So now what we have the center of gravity, that is the point where the entire weight of the body is concentrated, and we have center of mass where all the mass is concentrated. Okay, now there are different examples, and there are a lot of differences between them. Even though they are very, very similar to each other, there are certain differences between center of mass and center of gravity. Alright, so next video you will see what are the differences between